Hello everyone and welcome to my capstone presentation. Today we're diving into an exciting question. Why do so many drugs resemble the structures of serotonin and dopamine? So these tiny molecules have an enormous impact in our brains, mood, and even how we perceive the world. So let's explore and see how chemistry helps us understand and mimic their powerful effects. To kick things off, the goal of this project is to uncover the chemical principles that explain why drugs are designed to look like neurotransmitters such as serotonin and dopamine. It's not just about copying their shape, it's about creating a perfect match that can influence how our brain functions. So by end of this presentation, you will see how these molecules connect chemistry, health, and even happiness. Let's start with serotonin, famously known as the feel-good molecule. It regulates mood, sleep, and appetite. When serotonin levels are too low, it's often linked to depression and anxiety. But what makes serotonin so special? It's all in its molecular structure. Its shape allows us to fit perfectly into specific receptors, like a key unlocking a door, sending signals that makes us feel calm, happy, and content. Next, we have dopamine. It's all about reward, pleasure, and feeling good. But it's not just about feeling good, because dopamine also controls motor functions and is tied to conditions like Parkinson's disease and addiction. What's fascinating is how its molecular structure allows to interact with the brain's reward pathways, making it essential target for drug design. And now chemistry gets cool, because neurotransmitters like serotonin and dopamine use the key lock model to communicate. Their molecular shape acts as a key that unlocks specific receptors in the brain. But here's the catch: if the shape doesn't match, the message doesn't get through. This is why understanding molecular geometry is so important. It's the foundation of how our brain chemistry works. So why do drugs mimic neurotransmitters? Imagine designing a key that can unlock or even block a specific door. So drugs are carefully engineered to resemble these natural molecules so they can interact with the same receptors. For example, antidepressants are like master keys that amplify serotonin levels, while other drugs block dopamine pathways to treat addiction. It's like hacking the brain with the chemistry. And now, the real magic of chemistry shines, because scientists use a process called SAR to tweak drug molecules. These adjustments affect how long the drug works, how strong it is, and even how safe it is to use. It's like fine-tuning a recipe for the perfect result. And these are the main takeaways from this project. Before wrapping up, I wanted to thank my professor and classmates for their support. This project wouldn't be possible without the research and the resources that have guided me through this journey. Thank you so much for watching. I hope this presentation has sparked your curiosity about the connection between chemistry and neuroscience. If you have any questions, or if you are as fascinated by serotonin and dopamine as I am, let's talk more. Until then, stay curious and keep exploring the wonders of science.